Welcome back, physics fans. Here we are on relative velocity. This is our third lesson in, oh, there goes the blank screen again. Third lesson in Chapter 1 on constant motion. Constant motion. So let's go through this on relative velocity. How fast does your uncle drive? That's kind of like a relative velocity one. Relative motion is the difference in velocity between the two objects. That's an important one. It's relative. There it is. There's our definition. How do you know it's a definition? Well, it says our term, and it has the word is. So it's a good, always kind of look for that type of stuff in your readings. In fact, it's impossible to have a velocity without having something to compare it to. If a car is moving at 60 kilometers an hour, you're referring to the car's motion to the road. But that road is not actually stationary. The planet is actually moving. This concept is confusing. Okay, and it's confusing when we have our two objects that are in relative motion with respect to each other. Okay, the easiest way to determine the relative speeds is to imagine what the situation looks like from the other observer. So sit on the car, take a look at what he sees, and take a look. We normally just are the observer standing on the side and we see these two velocities, but we have to do relative velocity, okay, relative to each other. So there's two examples of relative velocity when they're moving towards each other, and down below here we'll see that they're actually, one is moving away or trying to move away, but the other one's trying to catch up. So in this example number 1, we have car A moving at 35 meters per second east. There's a vector representation of it. And a car here is 15 meters per second west. There's our vector representation of it. From the viewpoint on car A, it would seem though he is stationary because you're sitting in the car and the car is stationary around you. The road's moving below you. But car B is moving towards him at 50 because we have to add up his speeds. I'm not going to go into that right now. And car B would also see that he's moving. So this car is moving towards him at 50 and this car is moving towards the other guy at 50. It's relative velocity and we have to add. So if they're going in opposite directions, if they're moving in opposite directions, we have to add the velocities. Now the trick also to it is, what happens if they're moving away from each other? We still have to add. It doesn't matter. If they're towards each other this way or away from each other, we have to add, and that's the rule. Okay? Consequently, if the objects are moving in the same direction, okay, we have to actually subtract. We have to subtract if they're moving in the same direction. So this guy is trying to catch up to this guy, so we have to actually subtract. So the relative velocity in this case is going to be 35 minus 15, which is going to be 20 meters per second. The relative velocity in this guy above is going to be 50 because the relative is going to be 35 plus 15. So that is equal to 50 meters per second. Now, I'm using V and I'm using the word velocity. Doesn't this need a direction? Because it is a velocity? And yes, it is a direction. Which direction is it? East or west? And the answer is yes. It's both. For this guy is 50 meters per second east, and for this guy's moving 50 meters per second west. So the answer is 50 meters per second. Which direction? It's both, depending on who you're observing with. It's relative to who's observing it. What formula do we use now that we got a velocity? We used our simple formula that we've developed in lesson 1 and used in lesson 2 for average velocities. We also use it for relative velocities, V equals d over t. Just in this case, the d is not the distance that car B is moving, and d is not the distance that car A is moving. D is the relative distance between them. because we're using relative velocity. Huh? Okay, well, let's just take a look at it. Let's look at example number 3. Nathan is running at 6 meters per second, this is on the back side, and is trying to catch up to Michaela, who is 150 meters ahead and is running at 4. So we have Nathan, and he's running at 6 meters per second. Okay, and then we have Michaela, let's have the long flowing hair, is 4 meters per second and running that way. And the distance between them, initial, because they're going to catch up, so the initial starting distance is 150 meters ahead. Okay? So we go, they're both moving. So they're both moving, so it's now a relative velocity question. So V-rel is going to be 6 and 4 are my two numbers. Do I add or subtract? Since they're both headed in the same direction, I have to subtract. So the relative velocity is 2 meters per second. The relative distance, how far apart are they, is 150 meters. So the only other term that we don't have here is the time. So the time is going to be distance over velocity, or displacement over velocity, distance over speed, whatever. And d is going to be 150 meters, and the speed is 2 meters per second. So this is going to take 75 seconds. So it's going to take Nathan 75 seconds to catch up to Michaela. Okay? What is the most important part of this answer that I have here? Well, you have to tell me, the marker, okay, that it's a relative velocity question, and that when they're in the same direction, you have to subtract. So what I highlight in yellow there is important for me. I give that a mark. If you just went V-rel is 2 meters per second, you've missed out the fact that I'm looking to see that you can explain that I need to take the two speeds and subtract them to get the relative velocity. That's what's new in this lesson. Why would you skip that? So please, that is one mark to write that all out. It seems like, do I have to? Yes. Okay? Part B. It says, how far has Michaela run during this time? So this is just Michaela. It's only one, not both. Only one of them is running. So you don't take the relative velocity. You do the velocity of Michaela, and that is 4 meters per second. And the time that she ran was 75 seconds. So how far did she run? Michaela ran, well, we have to go velocity times time. Velocity is 4 meters per second, and the time was 75 seconds. So that is going to be 300 meters. Okay? And if you wanted to do a little bonus work, part C, it's not asking you, how far did Nathan run? Nathan ran at 6 meters per second for 75 seconds. So 6 times 75 is 450. But we also knew that was 450 because if Michaela ran 300 and Nathan also caught up 150 more, so we add those together, and there's a little check if you wanted, we add those two together, the same. Okay, so try these questions down below. And you have to determine, is there a time where there's one moving, and if it's only one, then you take the distance and the time, and that one velocity. Or if they're both moving, then you have to do relative velocity. Relative velocity. Okay. Thank you. Enjoy.